Good day, everyone. Once again, we're going to get into our next lesson for this Algebra 2 class. In today's lesson, we're going to be talking about lesson 2-2, which is graphing a system of inequalities, okay? So we've been dealing with graphing. We talked about it last section where we develop an equation, we graph it out, we actually see certain values that would work within the graph. On top of the fact, we've already talked about inequalities earlier with absolute value, okay? Now we're trying to combine both of them together. Not only are we dealing with graphing, but we're also dealing with graphing an inequality, okay? So let's go ahead and talk about some skills that we'll need to know kind of going into the lesson. The first thing that we're going to talk about is graphing just y equals mx plus b. Just a quick review on actually how to graph this out. Please remember when we do this, our goal is to try to remember if I'm given this type of equation, y equals 3x plus 2, I can automatically assume my slope is 3, and that will represent the rise over the run. And then the plus 2, well, that's going to be my b value or my y-intercept, okay? Well, now, to actually graph this out, all I have to do is start off with my y-intercept, which is at 2, and just come over here and plot a point at 2. And then my slope, which was 3, which determines my rise and my run, well, that's basically saying my rise is 3, and because I don't have a number on the bottom, my run is just considered to be 1. So I'm going to start at the 2 and count up 1, 2, 3 over 1. Little marking there. Let me get rid of that so it doesn't confuse anyone. Same thing. I'm going to go to that point now and go up 1, 2, 3 over 1. And then from there, I have an actual line created. Okay. Now, to kind of continue talking about this one, I want to show you different types of opportunities to actually how to graph, okay? Now, on this next one, we have this form right here, 2x plus 3y equals 6, okay? We call this standard form, all right? This is standard, okay? Now, the reason I bring this up and the reason why I think this is important is because this is another opportunity of graphing, okay? I'm given a different equation than what I'm given here on the first page. Notice how I was given y equals mx plus b, so I could use that material. In this page, I'm not given it, okay? Both the x and the y are on the same side, all right? So to solve this one out, it's basically just taking 2 steps, okay? What I'm going to do is basically plug in a 0 for both the y and the x at different portions. So if I want to actually graph this out, it's pretty easy 2 steps. In the first step, plug in a 0 for the x. Anything with a 0 is automatically cancels itself out. So 2 times 0 is going to be 0. So all you have to do here is divide out the 3 to get y equals 2. Come to the graph and just find the y-axis in 2 and plot a point. Now to find your second point, all you have to do is do the same thing, but now instead of plugging in 0 for x, I'm going to plug in a 0 for the y. Automatically cancels itself out, and I'm left with 2x equals 6. Oops, let me rewrite that. 2x equals 6. Divide out the 2 to get an x equals 3. Go to where the x-axis is, which is left and right, and go to positive 3 and plot a point. And then from there, 2 points can create a line, so I can go ahead and draw my line through those 2 points, okay? So notice how these are 2 different forms of graphing, and it's fairly easy overall, right? In this form, we're given 2 different coordinates, a starting point and a y-intercept. In this form, even though we're given a different equation, we can still graph it fairly easy just by using our resources. All we have to do is remember our steps, which simply put, we are going to plug a 0 in for the x, and then we plug a 0 in for the y and solve for each. However, when we're actually getting into this lesson, we have to talk about how does this differ? How do we graph an inequality? Okay, so when I look at this problem here, we have y is greater than 3x plus 2. Okay, in this actual graph, and on top of that with this question, I'm going to ask what changes from the last graph that we did. Well, to graph this out, I'm going to follow my same steps. We have an m equal to 3, so that's our slope, and we have a y-intercept, or b, equal to 2. So we start at 2, and then we just count up 3, over 1. Up 3, 2, 3, over 1. Here's where it differs. First off, when I'm given a graph with with a inequality in it, first and foremost, I have to assume that because that's saying that y has to be greater than that, I can't assume that everything on this line is right. So what I need to do is, when I draw my line, I have to make it a dotted version of it. So I'm going to draw a dotted line through those coordinates. The main reason is because I'm saying by drawing a dotted line that any coordinate that passes through it technically can't be an answer, because as it will equal this side, it will not be greater than it. So now I have to figure out, okay, well then how do I figure out what's my next step? This is where the review comes in. An inequality can be tons of answers. Okay, it doesn't have to be a singular answer for this problem. It can be so many. Okay, for example, as long as this y value is bigger than what's on the right-hand side of the equation, it's a right answer. So we have to try to figure out what side of this graph actually holds the right answers. Okay, if you notice, this graph is split into two parts. You have the side on the left and the side on the right. One of these sides are all your correct answers. On the other side, it's going to be all your incorrect answers. And so what we want to do mathematically is figure out which side that is. So an easy way to do this is we're going to basically test a coordinate. So I'm going to test 0, 0. So I'm going to test 0, 0. If I go ahead and plug that in, we have 0 is greater than 3 times 0 plus 2. Anything times 0 is going to cancel itself out, and that would give me 0 is greater than 2. Well, we could all sit there and say that can't be right. That's an incorrect answer, right? 0 is not bigger than 2. So this was incorrect. So basically what I'm going to do now is assume that because this test point was on the incorrect side, that the actual correct side must be on the left here. Okay, if a point that's on the incorrect side is on the right, that means on the other side, all the correct answers have to be there. So what I have to do now is just shade everything over on this side of the line, indicating that all of these coordinates are correct, versus everything on this side is incorrect. Okay? And that's basically why we do these problems, how we actually look at this. It's the whole reason why we shade and we even graph it out. Okay? Inequalities don't have to be a single specific answer. They can be many possible answers. So our shading just tells us this side of the graph are all our correct answers, while the other side's all the incorrect. So with that information, let's go ahead and talk about the lesson itself. Okay? In this lesson, we're going to start to develop equations and actually try to build constraints off of them. So in this first lesson right here, we have to understand some basic information. Okay? First off, from the last lesson, we have tickets and meals. Now, if you remember correctly, tickets cost $100 each, while the meals cost $40. Okay? So what we want to do is be able to figure out, is the total cost feasible and does it actually work? Now the last piece of information that you have to remember is we had $13.60 total. Okay? All this information came from the last lesson. All that stuff is basically what we have given to us right now. So we want to try to figure out, do these situations work? Okay? Well, in this first problem, we have 6 tickets and 16 meals. All right? Well, to figure that out, to actually figure out this problem, what I would need to do is take 100 times 6 plus 40 times 16. 40 times 16, and basically see what is that going to be equal to. Okay, that's how I would figure out this portion right here. Well, if I actually work that out, I would get a value of 1240. So the total cost of all that would be $1,240. And this question basically, is it feasible? It's a pretty straightforward question. It's basically saying, can you do that? Well, because 1240 is less than 1360, yes, you can afford that. And with the rationale, basically all it's saying is write it mathematically. Well, this works because 1240 is less than or equal to 1360. In the next value, we have 8 and 14. Well, if I actually work this one out using the same exact math, that would give me an answer of 1360. Which, once again, is it feasible? Yes, because this value is less than or equal to this value. And even though it's equal to one another, I'm still going to write it as an inequality because anything that is less than 1360 or equals it works, right? Like I could have $1,000 and it still works. So I want to keep this terminology because it's still describing that, hey, it's going to work as long as it's below or equal to 1360. So now let's talk about the 10 and 12. If I work those out, this is 1480. Is it feasible? In this case, no. It doesn't make sense. Okay? So for this case, now I can simply put that 1480 is greater than or equal to 1360. Okay? It doesn't work because 1480 is too big. And in the last problem, 4.5 tickets and 11 meals. Is it feasible? Technically, yes. But we do have a little bit of a problem here. Okay? The real problem we have here is this one. And this is where it becomes like real world situations. If you have 4.5 of a ticket, basically you're attending half of the actual show. I don't know how many movie theaters or any plays you've been to where they'll just be like, yeah, you can pay for half of it, but you have to leave halfway through. Okay, see how that doesn't really work? Real world situations really can't have decimal answers for a lot of them. Okay, you can't have like half a person. Okay, it just like things like that do not work in math. So when I talk about is this feasible, the money wise, yes, but in reality, like it doesn't work. So it's because the ticket is 4.5, the reason why it's no, not feasible. Okay? So now, basically, down here, what they want to do in number 3 is write a linear inequality. What this basically means is we want an equation that describes everything. Well, let's use this problem to our advantage. Think about what you did, all right? Every single time we were to solve these out, we would take the tickets times 100, the meals times 40, and basically say, is it cheaper than 1360? So I'm going to use this to help me write an inequality. The easiest way to do this is really just to think about it. It's 100 times what? Well, it's how many tickets you actually buy, right? In this case, we had 6 tickets. Well, if I want to write that as just an inequality or like an equation, it's just going to be 100 times t. I'm going to add that to how much our meals cost. Well, it's $40 per meal. And m is what I'm going to state for my meals. Now, the last piece of information is where it gets important. We want to try to make it as an inequality. Well, how do we do that? This is where you really want to try to think logically. Think about the problem. Well, in every single one of these situations, our goal or our rationale was to say, is it less than our total? Well, I need to actually represent that within our inequality. So I'm going to sit here and say, this side of the equation, our tickets and our meals, have to be less than or equal to our total, which is 1360. Okay? And from there, we have an inequality. Now, we can even go more in depth with this. For example, in number 4, we can actually use this to our advantage. If Roy buys exactly 2 meals each day, determine the total number of tickets that he could purchase in 5 days. Show your work. Well, if he buys 2 meals each day and you have 5 days, 2 meals each day, and you go for 5 days, then you know you have 10 total meals. So to solve this out, you're just going to take 100t plus 40 times 10 less than or equal to 1360. This comes out to be 100t plus 400 is less than or equal to 1360. And now we're going to treat this just like an algebraic problem. Even if we have an inequality, we're going to treat it the same way. We subtract the 400. This will give us 100t is less than or equal to 900, or excuse me, 960. 960. And then our last step, we have to divide out that 100 to get that our tickets have to be less than or equal to 9.6. Now, if I want to make this equation truthful, or I want to actually make it right, I can't have this 0.6. Okay, I can't buy 0.6 a ticket. So basically, I have to assume that our tickets have to be less than or equal to 9. Okay, and that would be our final answer. So now let's just talk about how we can make this work. Okay, if I go down to number 8 here, let's just quickly graph this out and talk about how this affects our problem and really what could I do in this situation. Well, to do this, I need to follow the same rules we talked about in the previous lesson. If we have 100t plus 40 meals is less than or equal to 1360, what I want to do is try to think, okay, well, how could I make this work in an inequality? How could I graph this out and actually make this work throughout the problem? Well, this is when I want to use that standard form. Okay, notice how this is the same thing as like having an x and a y, right? I want to try to figure out my extremes. I want to try to figure out my y and my x intercepts. What is the maximum tickets I could have? What is the maximum meals I could have? Because in turn, if I do that, I'm actually going to create a graph for myself. So let's go with this first one. Let's plug a 0 in for tickets. Let's say we bought 0 tickets. What's the maximum amount of meals that we could have? 1360. Well, this would cancel itself out. So all we have to do is divide the 40. This would give us meals have to be less than or equal to, meals have to be less than or equal to 1360 divided by 40 would give me 34. Okay, so now what I'm going to do is I'm going to go to the meal side, go up to 34, plot a point. In my next portion now, I got to do the same thing, but now I want to figure out what's the maximum amount of tickets I could have. Well, this would be 100t plus 40. If let's say I get 0 meals is less than or equal to 1360. This cancels. I need to divide by 100 to get t is less than or equal to 13.6. Now, we already talked about how you really can't have 0.6 of a ticket, but in this turn, in graphing it, we can go ahead and plot that on there. So we want to go to 13.6 and plot a point. Now, if you notice, I've created 2 coordinates on this graph, right? I have a coordinate here and a coordinate here. Well, because of that, I can actually create a line just with those 2 coordinates. I don't need any like special trick or anything like that. Just by finding those 2, I have a line. So what I'm going to do is I'm going to connect this together. But now here's the next important thing to understand. In the previous part of the lesson, we had a less than and an equal to. And because of that, we ended up doing a dotted line because we cannot equal those values. Well, now, if I'm given a less than or equal to or a greater than or equal to, what I'm going to do is I'm going to use a solid line because I can actually equal those values, okay? This represents that you cannot equal those values. This one straight line represents that you can equal those values, okay? So in this situation, because I have an equal to value, I'm going to go ahead and draw a line through those points. Ooh, we can do a little better than that. There we go. Through those coordinates, in which now I have a single line that states anything that crosses through that graph actually works. But there's one last thing we have to do here. I have to think, okay, this is an inequality. which means on certain side here, I should have right situations. Either this side is correct or this side is correct. So I'm going to follow the same rules. I'm going to test a point. I'm going to test 0, 0, and basically say if I bought 0 tickets and 0 meals, would this situation work? Now, a lot of you are probably saying, like, that doesn't make sense. Why would you go to this New York, not eat at all, and not buy any tickets? And you're right. It's an extreme idea. You probably wouldn't do that. But if we're thinking mathematically, like, would this actually work? Then yes. So what I would want to do is I want to test that coordinate. I'm going to plug in 0, 0 into this problem. If I bought 0 tickets and 0 meals, this would be 100 times 0 plus 40 times 0 is less than or equal to 1360. Well, that would cancel. That would cancel. This would give me 0 is greater than, excuse me, less than or equal to 1360, which is a true statement. Because of that, everything towards that point, so notice all this area down here, has to be shaded in. And that would mean any coordinate that's in there has to be a correct answer. Okay? We're also stating that this side, any coordinates in there are incorrect. Okay? That is it for today's lesson. Thanks for watching. If you have any questions, bring them to class tomorrow and we'll discuss them there. Besides that, have a great day.